Okay, let's tackle some Alex types problems on quantum numbers, and I've got three of them for us here. Here's number one. Here is number two. We'll tackle, and then down here is number three. But let's quickly review what the quantum numbers are and kind of what they represent. So the first one that we're going to have the principal quantum number n. N can start with 1, it can be 2, 3, 4, and so on up into infinity. Okay, so this represents the principal quantum number. The next one that we have is the angular momentum, which is the L. Okay, so we have L as our angular momentum, and that can assume values starting at 0, 1, 2, 3, and so on up until n minus 1. Can never equal n. What this also means is these are representations of if L equals 0, then that is an s orbital. If L equals 1, that is a p orbital. If L equals 2, that is a d orbital. And if L equals 3, that is an f orbital. And we talked about those in class. The last type of quantum number that we really talked about is the magnetic quantum number. Okay, so this is going to be m sub L. And that is going to equal from minus L up until a positive L. Okay, so for example, if L equals 3, then m sub L can equal a minus 3, a minus 2, a minus 1, a 0, 1, 2, 3. These represent the number of shells, of orbitals that are in this if L equals 3. Okay, so each of these orbitals can contain 2 electrons. So in f orbitals we can have a total of 2, 4, 6, 8, 10, 12, 14 electrons. So these are just reviewing some ideas around quantum numbers. So let's look at these questions now. What is the smallest possible value of the principal quantum number n for a p electron? Okay, so let's think about this. Let's say if n equals 1, the smallest that it can be, if n equals 1, then L can only equal 0 because L can only go up to n minus 1. Remember, 0, if L equals 0, that's an s orbital. So there can be no p electron if n equals 1. So let's think now if n equals 2. If n equals 2, then L can be 0, and it can also be 1. So this is an s orbital. L is, or 1 is a p orbital. And so the smallest possible value of the principal quantum number for n, the answer for this would be 2. Okay, so let's move over to the second one. List all possible values of magnetic quantum number ml for a 3d electron. For a 3d electron. So we have a principal quantum number of 3. It's a d electron. If it's a d electron, then L has to equal 2. Okay, because that's what a d electron is. And so what are the possible values for m sub L? Well, m sub L goes from minus L up to L, and so this is going to, if L equals 2, which is what a d set of orbitals would look like, then that is going to be minus 2, minus 1, 0, 1, and 2. That's minus L up to L. This is what I would type into ALEKS. Are these numbers just like that? Okay, so there are in the d orbitals, there's 1, 2, 3, 4, 5. Just for our information, there are 5 d orbitals. And if each of those orbitals can contain 2 electrons, that would mean that the d orbitals contain 10 electrons total. Okay, so this is what I would write into ALEKS. This other stuff I just wanted to bring up. Okay, let's answer this last one. You'll see problems like this. Okay, fill in the information missing from this table. Okay, it's asking for the principal quantum number. Well, the principal quantum number is given out here in front. Okay, so this would be easy. So this answer would be 5. This would be 2. This would be 4. Okay, the angular momentum quantum number. Okay, that's our L, our angular momentum quantum number. And so if it's an F orbital, okay, if it's an F orbital, then that has to be 3. So I'm just going to write a 3. If it's a P orbital, then that is a 1. That's a 1. And if it's a D orbital, then that is going to be 2. Just getting that information from right here that I wrote down. Alright, the maximum number of electrons in an F orbital. We already did this F orbital. F orbital is if L equals 3. And here are all the possible numbers. So, since it goes from minus 3 to plus 3, that is 1, 2, 3, 4, 5, 6, 7. That in the F orbitals is going to be 14 electrons. In the P orbitals, okay, so P orbitals, if L equals 1, which is a P orbital, that means that the m sub L, the magnetic quantum number, will be minus 1, 0, and 1. If each of those contain 2 electrons, there's 2, 4, 6. There are 6 electrons. And finally, the d orbitals, we already sort of did this one up here. Okay, the d orbitals means that L equals 2. If L equals 2, then m sub L is going to equal minus 2, minus 1, 0, 1, and 2. There's 1, 2, 3, 4, 5 d orbitals. If each of those contain 2 electrons, which they do, then the maximum number of electrons would be 10. So that's how you would fill in this table right here. So it's just a matter of kind of remembering what each of the quantum numbers are, what they mean, and then just applying them to answering these questions.